Good morning students, as this welcomes you all. Now we are ready with our new numerical, that is a closely wound solenoid of 2000 tons at area of cross section 1.6 into 10 power minus 4 meter square, carrying a current of 4 ampere is suspended through its center, allowing it to turn in a horizontal plane. In the first part it is asking about what is the magnetic moment associated with the solenoid, and in the second part it is asking about what is the force and torque on the solenoid if a uniform horizontal magnetic field of 7.5 into 10 power minus 2 Tesla is set up at an angle of 30 degree with the axis of solenoid. We have to solve this numerical one by one. So first of all, let us see what are the quantities which are given here. The very first quantity which is given here, that is N is equal to 2000 tons, and the second one is A is equal to 1.6 into 10 power minus 4 meters square, and the third one is I is equal to 4 ampere. Let us solve this numerical one by one section. That is, in the first section it is asking about what is the magnetic moment associated with the solenoid. So since we know that M is equal to what? NIA, we have to only multiply these quantities. These are very simple numericals, very easy numericals. I is what? 4 into A 1.6 into 10 power minus 4. We just solve this. This one can be 4 to the 8. This one can be like 10 power minus 4. This one can be like 1.28 joule per Tesla. In the first part it was asking about magnetic moment associated with the solenoid. We have solved this, that M is equal to NIA. We have used only the formula and we have multiplied all the relations and we got the answer, that is 1.28 joule per Tesla. In the second part it is asking about the net force and the torque associated with it. The net force and the torque associated with it. So just let us see how will we solve the second one. It is asking about the net force. Always remember the net force of solenoid would be equal to 0. Net force of solenoid is equal to 0. And what is the torque it is asking about? Tau is equal to, we know that, mb sine theta. So here B is given. B is what? 7.5 into 10 power minus 2 Tesla. What is B? B is 7.5 into 10 power minus 2 Tesla. So we just solve this value. We are having the value that theta is 30 degree. So we are just putting the value that tau is equal to 1.28. We have got this answer we have just got. And B is what? 7.5 into 10 power minus 2 into sine 30 degree. This can be like 1.28 into 7.5 into 10 power minus 2 into 1 by 2. We just solve this. You can solve this out. That 2.64, and this one is like 75. Point and point. It is 0.64 into 7.5 into 10 power minus 2. This one can be 4. And this one can be 4.8 into 10 power minus 2 Newton meter. So the answer what we got, that is 4.8 into 10 power minus 2 Newton meter. So once again just recall this numerical. This numerical was lengthy, but do not worry about the numerical, only the formula of this numerical it is. That is what? A closely wound solenoid of 2000 tons and area of cross section 1.6 into 10 power minus 4 meters square, carrying a current of 4 ampere is suspended through its center, allowing it to turn in a horizontal plane. What is the magnetic moment associated with the solenoid, and what is the net force and the torque on the solenoid if uniform horizontal magnetic field of 7.5 into 10 power minus 2 Tesla is set up at an angle of 30 degree with axis of solenoid. So we have just got the value, what the values are given. N is equal to 2000 tons, A is equal to 1.6 into about 10 power minus 4 meter square, I is equal to 4 ampere. Then we just in the first part we have used the relation, that is M is equal to Ni, and in the second part we know that the net force of solenoid would be equal to 0, and here the torque can be given like mb sin theta, and the values are given. We have just put the value and we got the answer. I hope you got this numerical. As this, will see you again next lecture. Thank you so much.